First problem is the magnifying power of a telescope is 9. When it is adjusted for parallel rays, the distance between the objective and eyepiece is found to be 20 cm. The focal length of the lenses are option is 18 cm and 2 cm, option B is 11 cm and 9 cm, option C is 10 cm and 10 cm, and option D is 15 cm and 5 cm. The magnifying power we know for telescope is m equal to, for normal vision, it is minus f naught by fe, where f naught is the focal length of the objective and fe is the focal length of eyepiece. It is given that magnifying power of the lens is 9, so m equal to minus 9. Minus refers that image are inverted. This implies that minus 9 is equal to minus focal length of objective divided by focal length of eyepiece, or we can say focal length of objective is 9 times of the focal length of eyepiece. This is the equation number 1. For normal vision, we know that the telescope length, that is equal to the distance between the objective and the eyepiece, is FO plus FE, and it is given 20 centimeter. This is our equation number 2. Solving equation number 1 and 2, by substituting the value of FO in equation 2, we will have 9 FE plus FE equal to 20 centimeter. This implies that 10 FE equal to 20, or FE, that is the focal length of eyepiece, will be 2 centimeter. To find the focal length of the objective, we put the value of FE in the equation 1. So we can say from equation 1, focal length of objective is 9 times of focal length of eyepiece, and it will be equal to 9 into 2, that is equal to 18 centimeter. So focal length of objective is 18 centimeter, focal length of eyepiece is 2 centimeter, hence option A is the correct option. Second question is, an astronomical telescope has an angular magnification of magnitude 5 for distant object. The separation between the objective and the eyepiece is 36 centimeter, and the final image is formed at infinity. The focal length f naught of the objective and the focal length fe of the eyepiece are, options are f naught equal to 45 centimeter, fe equal to minus 9 centimeter. Option B is f naught is 50 centimeter, fe is 10 centimeter. Option C is f naught equal to 7.2 centimeter, fe equal to 5 centimeter. And option D is f naught equal to 30 centimeter and fe equal to 6 centimeter. This is the question similar to the previous question. Here image is formed at infinity, so this is the case of the normal vision. And for normal vision, magnification is given m equal to minus f naught by fe. Magnification is given 5, so m is minus 5. Minus is used because image is inverted. It will be equal to minus f naught by fe. This gives f naught equal to 5 fe. This is our equation number 1. Also, it is given that the separation between the objective and the eyepiece is 36 centimeter. In normal vision, this separation is the sum of the focal length of objective and focal length of the eyepiece, also called the length of the telescope tube. It will be equal to 36 centimeter. This is our equation number 2. Put value of f naught in equation 2 from equation 1. We will get 5 fe plus fe equal to 36, or 6 fe equal to 36. This implies that fe, that is the focal length of the eyepiece, will be 6 centimeter. And now put the value of fe in equation 1. So from equation 1, f naught, that is the focal length of the objective, will be equal to 5 times of the focal length of eyepiece, and focal length of eyepiece is 6, hence focal length of objective will be 30 centimeter. So option D is the correct option. Third question is, an astronomical telescope has objective and eyepiece of focal length 40 centimeter and 4 centimeter respectively. To view an object 200 centimeter away from the objective, the lenses must be separated by a distance of, options are 50 centimeter, 54 centimeter, 37.3 centimeter, and option D is 46.0 centimeter. It is given that focal length of objective is 40 centimeter. The astronomical telescope uses both the lenses as convex lens, so their focal length will be positive. Focal length of eyepiece is given 4 centimeter, and the distance of the object from the objective is 200 centimeter. If we draw the figure, say this is the objective which have the focal length 40 centimeter. From the optical center of this lens, there is an object O which is at a distance of 200 centimeter. So we can find the from distance of the image from the lens formula. This will be equal to 1 by 40 equal to 1 by V, which we have to find, minus 1 by, and because this 200 is the distance of the object from the lens and it is on the left hand side, so we will take it as minus. Hence 1 by V equal to 1 by 40 minus 1 by 200. Taking LCM 200, it will be 5 minus 1, that is equal to 4 by 200, or it is equal to 1 by 50. So V will be equal to 50 centimeter. Because V is positive, so image will be on right hand side of the lens. So we can form the image. One of the rays taken through the optical center which move undeviated. Another, say we take parallel to the principal axis, so it will pass through the focus, and the ray cuts at some point on which we find the image I, and this distance of the object image I from the objective lens is 50 centimeter. Now for normal vision, the eyepiece is kept such that image is formed at the first focus of the eyepiece. This is the eyepiece E, and F2 is its first focus. So this distance is Fe, that is the focal length. So if we make the image from the eyepiece, the one of the rays parallel to the principal axis, so after refraction it passes through the second focus of the eyepiece, and one ray is taking which is passing through the optical center, so this ray passes without any deviation, and on backward tracing these rays appears to come out from the infinity, so image formed at infinity, and we say this is the normal vision of the image formation. Therefore we have to find the separation of the lenses, that is objective and eyepiece. Here the distance of the image I from the objective is 50 centimeter, which we have calculated, and it is given that the focal length of the eyepiece is 4 centimeter, and this is the distance of the eyepiece from the image I. Therefore separation between objective and eyepiece will be equal to 50 centimeter plus focal length of eyepiece, that is 4 centimeter, and it is equal to 54 centimeter. Hence option B is the correct option. Fourth question is, the focal length of objective lens is increased. The magnifying power of the telescope, options are increases, decreases, option C is remains unchanged, or may increase or decrease. We know that magnifying power of the telescope is minus f naught by Fe for normal vision, that means when image forms at the infinity, or it may be minus f naught by Fe 1 plus Fe by d when image is formed at the near point, that means d equal to 25 centimeter. From the formula of magnification, we can extract that magnification of the telescope is directly proportional to the focal length of objective. So as focal length increases, magnification will also increase. Therefore, the magnifying power of the telescope will increase on increasing the focal length. So option A is the correct option. Fifth question is, an astronomical refracting telescope will have large angular magnification and high angular resolution when it has an objective lens of, options are small focal length and large diameter. Option B is large focal length, small diameter. C is large focal length and large diameter. And option D is small focal length and small diameter. We know that the angular magnification M is equal to beta by alpha, where beta is the angle subtended by the image at the eye and alpha is the angle subtended by the object. This is equal to minus f naught by Fe for the normal vision, and minus sign is used to show that image is inverted image. So we can say that magnification is proportional to the focal length of the objective lens. So to have the high magnification, the focal length of the objective lens should also high. Similarly, for angular resolution, we know that the angular separation delta theta is equal to 1.22 lambda by A, where lambda is the wavelength of the light used and A is the diameter of the lens. Here objective lens. This angular separation delta theta, in terms of the angular resolution, we can say that for higher angular resolution, this delta theta should be smaller. So for smaller angular separation, that is higher angular resolution, we can say that delta theta is inversely proportional to the diameter of the lens. Therefore, to have the smaller delta theta or angular separation, this diameter should be larger. Therefore, we can extract that the focal length of the objective lens should be high, and similarly diameter should be large. Hence option C is the correct option. Sixth question is, four lenses of focal length plus minus 15 centimeter and plus minus 150 centimeter are available for making a telescope. To produce the largest magnification, the focal length of the eyepiece should be. Options are plus 15 centimeter, plus 150 centimeter, minus 150 centimeter, and option D is minus 15 centimeter. We know that magnification of the telescope is minus f0 by fe, where f0 is the focal length of the objective lens and fe is the focal length of eyepiece. Minus sign shows that image form is inverted image. To have the large magnification, the focal length of the objective should be larger and focal length of the eyepiece should be smaller. Here we are given the four lenses. One is having the focal length of 15 centimeter, another is minus 15 centimeter, third one is 1 plus 150 centimeter, and another one is minus 150 centimeter. We know that lenses used in the telescope are the convergent lens, that means convex lens, so the negative focal lengths are not allowed. And out of these two lenses, which are plus 15 centimeter and plus 150 centimeter, larger focal length will be used for the objective, so it is the focal length of objective, and smaller focal length will be used for the eyepiece. So this lens is the eyepiece. Hence, the focal length of the eyepiece should be plus 15 centimeter. Hence, option A is the correct option. Seventh question is, a telescope has an objective lens of focal length 150 centimeter and an eyepiece of focal length 5 centimeter. If a 50-meter tall tower at a distance of 1 kilometer is observed through this telescope in normal setting, the angle formed by the image of the tower is theta, then theta is close to. Options are 30 degree, 15 degree, 16 degree, and 1 degree. For this problem, first we will draw the diagram. This is the principal axis on which there is an objective lens. Focal length of the objective lens is 150 centimeter, and there is a tower of 50-meter high at a distance of 1 kilometer, that means 1000 meter from the objective. For image formation, we take one of the ray which passes through the optical center of the objective lens and passes without any deviation, and image of this tower AB is formed as A dash B dash. For normal setting, image is formed at the infinity, so the image A dash B dash will be at the first focus of the eyepiece, and focal length of the eyepiece is given 5 centimeter, and the one of the ray from the image A dash B dash through the optical center of the eyepiece will also passes through without any deviation, and in backward tracing the image is formed at the infinity. If we consider the angles, the angle subtended by the object is alpha, so this angle will also be alpha, and the angle subtended by the image is beta. Therefore, magnification of the telescope is minus f0 by fe for the normal setting, and this will be equal to beta by alpha, that is the angle subtended by the image and the angle subtended by the object, and it will be approximately equal to 10 beta by 10 alpha. Put the values. Minus focal length of objective is 150 centimeter divided by focal length of eyepiece, it is 5 centimeter, and it will be equal to 10 beta divided by 10 alpha. 10 alpha we can calculate as from the figure, that is the perpendicular by base. Perpendicular is the height of tower, that is 50 meter, and base is 1000 meter, so it will be equal to 120. We replace it here. This implies that 10 beta is equal to minus 150 by 5 into 120. Further simplifying, this 5 get cancelled, so it is 30. So it is minus 30 by 20. 0 and 0 get cancelled, so it is minus 1.5. This minus sign is for the inversion of the image, so we can ignore here, and this 10 beta will be equal to 1.5, and beta will be approximately equal to 56.3 degree. Hence nearest answer is option C. Eighth question is, a planet is observed by an astronomical refracting telescope having an objective of the focal length 16 meter and an eyepiece of focal length 2 centimeter. Now we have to select which statements are correct. Options are: the distance between the objective and the eyepiece is 16.02 meter. Option B is angular magnification of the planet is minus 800. Option C is the image of the planet is inverted, and option D is objective is larger than the eyepiece. We know that for a normal setting, the distance between the objective and the eyepiece is called the tube length of the telescope, and this tube length is equal to the sum of the focal length of objective and sum of the eyepiece. So this is the distance between objective and eyepiece in normal setting. So it will be equal to, the focal length of objective is 16 meter and focal length of eyepiece is 2 centimeters. So we have to divide by 100 to convert it into the meter. So we will have 16 plus 0.02, that is equal to 16.02 meter. So option A is the correct option. Similarly, for normal setting, the angular magnification is equal to minus f naught by fv, that is equal to minus f naught is given 16 meter and fv, that is the focal length of eyepiece, is 2 centimeter divided by 100, so it will be in meter. So we will have minus 16 by 2 into 100, simplifying it is 8, so it is minus 800. So option B is also correct option. And in telescope we know that the image is inverted image, so option C is also correct. We know that the resolving power of the lens depends on the diameter of the objective, and it is given by Rp equal to A by 1.22 lambda, where lambda is the wavelength of light and A is the diameter of the lens. So to have the higher resolving power, the diameter of the objective lens should be higher. So option D is also correct option.